Paul always suspected King Crab was more of a title than a name. And he wants to be the first human to bend the claw. Because one day, the crustaceans will rise, and only Paul will be spared. Foresight's a wonderful thing. Invest in innovation, including 3D printing, with Opto.
Welcome to Opto Sessions, Vijay. How are things?
Things are good. I am based in San Francisco, and the weather in July is very nice this year, but we are always ready for what we call Fogust, where the fog rolls in August. So I'm going to be ready for days of cloudiness.
Yeah, I've heard about that. Yeah, never actually experienced it myself. I mean, we were discussing before the call. The weather here in London is suitably sort of bleak, so at least you've got a bit of sunshine over there for now.
Yeah, that's important to hear. Hopefully you get some clear skies pretty soon.
Yeah, fingers crossed. So, I mean, I want to start by talking about Scale AI, introduce the company to any of our listeners that are unfamiliar with it. Then we'll talk about your products, the customers that you service, and then we'll finish by speaking about the wider kind of AI industry at large, or any future innovations you've got your eye on as well. But if we start with Scale AI, what do you do? Give us the elevator pitch.
Yeah, of course. Scale is an 8-year-old company, and we've been known as one of the leading companies in AI for many years now. We started with our founder, Alexander Wang's vision of how to build more trustworthy AI models, and he really focused on the data part of the equation first. What sort of data makes AI models more reliable, and how can you monitor or observe changes in that data and see how that impacts model performance over time? So an example of that might be work we do for self-driving cars, where if you want a car to reliably stop when there's a pedestrian across a crosswalk, the data you need to back that up might actually be pedestrians of all sorts, people walking their bikes across a crosswalk, all different sorts of real-world scenarios that help that model reach that safety milestone. So since we pioneered some of those techniques, we became one of the leading players in the development of LLMs today. We partnered with OpenAI on some of the data pipelines that led to ChatGPT. And that technique called reinforcement learning ended up being a really critical piece of most of the AI models that people use today, whether those are large language models, image models, multimodal encoding models now. The techniques around data that we use actually make most of the models that you use more reliable, more trustworthy, and better able to adapt to human operators and what we need to get out of these models. So because of that, a lot of our work today focuses both on the development of new models, which is incredibly important work to push this technology forward, but also work that we do with enterprises adapting AI into all sorts of industry use cases. So financial services, healthcare, education. What are the benchmarks you need to set up to understand whether a model can be used in financial services? And what are the goals that you need to try to get that into the hands of customers or employees this year? Lastly, we do really important work in the public sector as well. We know this is a very important technology, maybe the most important technology any of us will deal with in our lifetimes, but it comes with certain safety considerations. It comes with certain risks. So we spend a lot of time in the public sector finding ways to responsibly deploy AI and to try to get ahead of the future of how the public sector can think about this technology and help citizens understand the use of it as well.
Yeah, really interesting. And there's a few of those points that I want to come back to. But perhaps if we start with that, you mentioned the application of your technology within autonomous driving. And as I understand it, that's where the business started. So perhaps you can talk to us about that transition or that evolution from that original application to what you do now. How was that transition, and did that bring any additional challenges?
Yeah, it's really important to highlight how the development of self-driving as an industry has really paralleled a lot of important work that's happened with LLMs. And actually, more broadly, we use the term foundation models to talk about AI models that are at a certain level of sophistication, can talk with human language, or can understand images from cameras or other sensors. There's a whole category of models now that are multimodal, that work across both of those different types of domains of expertise. So we spend a lot of time in the first, kind of phase of this AI revolution, thinking about what data and how do you highlight that data that can specifically help a model understand the real world. What's called an embodied agent. An agent could be a model that takes actions in the real world, and an embodied agent would be an agent that has access to a car or a robot or something that can navigate the world around it. What kind of data helps that agent understand the world around it, given that we can't just be out gathering data about the real world at scale 24/7 just yet? So we pioneered some techniques to help identify whether these models need more data about the snow and how vehicles look differently in the snow, or whether it needs more data about open highways versus highways that might be weaving through city traffic. All sorts of interesting scenarios that can help these models improve. That pays a lot of dividends now in the world of large language models, because when you have a large model and you ask a question about biology, like ask any sort of a large model, explain to me biology like I'm a high schooler, and tell me about photosynthesis and how photosynthesis helps plants grow. The model may start off giving you a pretty decent answer, but you may realize actually halfway through the answer, the model got off track. It started explaining all these other concepts that a high schooler doesn't need to know, or it actually maybe started giving an inaccurate answer. It maybe said that photosynthesis is, something about, red algae or another plant or, another organism that has some different process. You can actually use biology PhDs, people with domain expertise, people with different backgrounds to help you understand these subjects better as a human being today. And we incorporate a lot of that finding into how we make models better. So we might ask a biology PhD, can you help me explain how to explain to this model how to improve its answer about photosynthesis? Maybe it should be a shorter answer. Maybe it should use more accurate sources. Maybe it should cite the references that it used in order to get its answer. It should cite a textbook, or it should cite, an authoritative page in a journal that you're using as part of the answer. And that can help the model be more accurate, give more actionable feedback to a human operator, and help that human operator on a learning journey understand the subject a lot better. So lots of ranges of benefits that you could try to get out of these models, and hopefully make this technology more useful for us in our day-to-day lives.
Yeah, absolutely. I think that biology example is really useful to help make this a little less abstract. I want to pick up on one of the points you mentioned earlier, and it was about that data centricity of your approach and how that, I guess, has become synonymous with trustworthy AI, as you also referenced as well. That,
Yeah.
as far as I understand it, that's kind of core to the business and the transition that you've gone through. But just perhaps you can, as you were probably about to, expand on what that means.
Yeah, it is actually the data-centric approach is incredibly important in finance in particular,
Yeah.
because one key finding that we had is that as large financial services firms, insurance firms have started to adopt this technology, they've realized that a lot of the value that you have in financial services is all of this data that you have that you keep internally within your organization. So that data could be information about your customers and how you want to talk to your customers about what they should be doing when they're saving for retirement or when they're thinking about wealth planning. It could be data about your own internal operations. How does your trading desk talk to someone that needs to consider risks of certain trades, or how do they, communicate to that team what their strategy is going forward? How can you look for patterns or changes and how that communication is happening over time? All of that data is incredibly important to drive your operations and to actually execute as a company. And with this new technology, you can now leverage that data in a way that you couldn't before. You can actually go through examples of how that trading desk talks over years or maybe a longer period of time and see, are there really interesting patterns in the language that people on the trading floor have been using? Do they talk about certain currency trades in a different way today than they did 3 months ago? Is that an early heads up that maybe I'm taking on certain degrees of risk that I weren't before that maybe the risk department isn't particularly considering? AI is incredibly capable of now synthesizing a huge range of human communication and trying to find patterns in there or observe what are nuanced changes and how that's working. So we're leveraging a lot of this data that's inherent in these enterprises in a very private, secure way to make these models answer questions that would have been difficult or timely or time-consuming for a human operator to do that with a level of accuracy that a human being would struggle to do. And we're trying to find the right models and the right AI systems that best set up that data pipeline. So we try to find models now that can answer questions of financial services really accurately. We've been really fortunate. Just yesterday, I think as we're taping this, Meta announced a new category of Llama models called Llama 3.1, and we actually evaluated how those models do in financial services. And we found that they give much more accurate answers than I think previous models had. They'll break down bullet points down when they're explaining a concept like cost of capital calculations, and they might correct an error in a calculation at a level of detail that we haven't seen before. So when we see that, we're really excited about this potential within the industry, and we try to leverage that. And we actually announced a strategic partnership with Meta as part of the Llama 3.1 announcement, so that folks can use those models within our scale Gen AI platform, which in turn financial services firms use in a private, secure way to build their AI systems.
Yeah, really interesting. Just on financial services as an industry that this technology is being applied, are they kind of a useful bellwether or gauge on how well a model is performing given the kind of nuance, the intricacy, the trustworthiness needed in that sector?
Absolutely. And that also goes back to the data-centric idea about AI, which is financial services is leading the way because they've been a regulated industry for so long, and
Yeah.
they've understood that data is at the core of a lot of what they need to get ahead of regulation and to explain to regulators how their business is operating. And so
Right.
they've done data governance well for years now. They understand what sources of data are really pertinent to answering certain questions. Where's that data found? What is the lineage of that data? Has that data been transformed in certain ways that changes characteristics of that data? All of that kind of data management is something that financial services firms in the modern economy have to do really, really well. And so that means they're actually set up to adopt AI much faster than many other industries. So the AI models, when they need to ask a question about wealth advisory, that there are people within the organization that understand really well how portfolio data for wealth advisory is stored, where research reports are stored, how you can identify gaps in that data. Let's say you don't have the right research report for that equity right now. How can you tell an AI model, hey, I don't have that report, and so maybe you should tell a human, ask a question. I don't have the right data at the moment to answer a question. Those are all really table stakes to have AI models give more accurate and actionable advice back to a human. So where we start off with financial services is trying to understand just how well that data is managed and what that means for these AI answers by doing that using testing and evaluation of the AI systems. So we might ask a wealth advisory question of a new AI copilot. We might ask that copilot, can you explain to a 65-year-old why they should be concerned about rising interest rates? But we might use models to actually help in the evaluation of those systems to try to understand how the data impacts the answers you're getting. So example of that might be, we might ask that same question, not just as a 65-year-old, but as a 40-year-old or as a 20-year-old. We might ask that question not just in the US, but in the UK or Canada. We might ask that question not just for someone who has a lot of holdings in US dollars or British pounds, but in euros and lots of different other currencies. And just see whether the model changes its answer, and whether sometimes it gives the answer that I don't have the right data to back up that conclusion. And that kind of testing evaluation helps you understand where you are today and where you need to be in the future in order to accurately answer customer questions or employee questions, how to actually have a copilot that assists people rather than holds them back because it's making assumptions about the data.
Got it. Yeah, really interesting. Well, so financial services, I guess, is one industry within the private sector that you're servicing at the moment. I heard you describe your overall customer base could be bucketed into three broad categories. Perhaps you can talk through each of those and give us a few examples.
Yeah. One category we start with are just those building models themselves, what we call the model providers. These are just a range of different firms today. It starts with the really large research labs. We had an amazing partnership with OpenAI that leading up to ChatGPT, and some of the techniques that we built there called reinforcement learning have ended up being really critical for this industry. Most researchers at some point studied these techniques, even if they might not directly use them on the models they're building, because they're just a really important bedrock of how we make models aligned with human expectations. So alignment is an industry term, which means that if you ask a question of the model, you ask the model to explain a particular trade to me. The model understands your question. It understands what actions it should take. It could potentially slow down and say, hey, I need to break this question down into multiple steps in order to answer this question accurately. But at any rate, it precisely follows the instructions you tell it to as a human, and it does that reliably. So alignment is a huge field and a huge category of work that's done by ML researchers. And so we've been really excited to pioneer some of the data techniques there. What we learn from work with model providers then translates into the work that we do with enterprises. So one of the reasons for that is that these models are becoming much more capable almost on a monthly basis. If I look back a year ago, the models were not very good at writing computer code. You'd ask them all to write Python for you. You'd ask them to write SQL for you. The model actually would give you pretty inaccurate answers, sometimes answers that were downright harmful to a human programmer because they didn't understand a lot of context on how code was written. But now you fast forward to today, and the models have certain capabilities, like they can use a larger range of data about your existing code base. They can answer questions in a variety of different languages. All of those capabilities make these models much more capable now in writing code. And we're seeing banks and financial services institutions use it in particular to write data analysis code, SQL code or Python code that can query data. So because the research is racing ahead and the enterprises are adopting these features pretty quickly, the work that we do to translate that research into action ends up being really, really important. So we spend a lot of time there helping customers first start with test and evaluation of the AI systems that they've already been trying,
Yeah.
help them understand why those systems might have been bottlenecked, why they might not have made it into production, which is pretty common in the industry today. I think if you ask folks whether they've been trying AI, they'll say, yes, we've been trying AI for a year. When we started a year ago, we maybe had 100 different groups within this bank that were trying different AI approaches across different organizations. But they come to today and they'll say, yeah, maybe only one or two of those are actually driving a lot of value for the bank. That the vast majority of them, they just didn't have the accuracy, or they just weren't safe enough to deploy it at scale.
Right.
And so we try to help them get over those bottlenecks by starting with testing and evaluation models and figure out what safety guarantees they need to have in place. Lastly, the third big bucket of customers are the public sector. They have really important considerations around safety there too, given public sector
Yeah.
data is often really sensitive. So we spend a lot of time with them on the safety guardrails that need to be in place. And we also spend a lot of time trying to find ways where AI can drive more actionable decision making. So an example of that might be having an AI model that doesn't just reply in a chat scenario, but might actually find different warehouses where you could get a part shipped from and plot that out on a map and show you the routes that part would take to get from one warehouse to where it needs to be in a way that can help someone in the field or an analyst to understand really quickly, these are my options. These are different sources of data that are really important to answer this question, and help that drive more actionable decision making where it's mission critical objectives.
Yeah, got it. I want to come back to the public sector because I think it's just a space, I guess, with I'm speaking more of a knowledge of the UK public sector, but with levels of bureaucracy, potentially inefficiencies that maybe the private sector isn't so familiar with. So interested to understand how AI can improve that situation. But before we move on to that, you've mentioned reinforcement learning a couple of times. It's at the heart of your partnership with OpenAI and the work that you did with their early models in the production of ChatGPT. But perhaps we can just dig into that and really kind of allow our listeners to understand exactly what that is and how it works.
Yeah, of course. Reinforcement learning has been a technique in the machine learning space that's been around for decades now. It's this idea that you can train a model not just by directly training the model itself, like not just telling the model, hey, go here and do this. But you actually train the teacher that can train the model, which oftentimes is another model that's just as capable as the model itself, but this model is being special built to be a really good teacher of other models. So ways in which you might give that teacher feedback might be not just directions, you go here to get there, but actually maybe feedback about negative things that you could do. So you could tell the model, hey, if you're going to start going down this path when you're writing a sentence, you're probably going down a wrong turn. You might be running into misinformation, or you might be running into something that's just a confusion that you have about the topic you're talking about. You could tell that teacher mid-sentence, hey, this isn't the way to go. The teacher is actually really good then at giving feedback to the model that you're trying to train. And that feedback could take a variety of forms. One of the most important ones is that the answers that the model that you're training needs to give need to be precise. They need to refer to real factual data, objective data. They need to tell the human what are the sources of data that I'm using in order to answer this question if they are, sources that the human wouldn't expect. And the answers also need to be really accurate in certain areas. So if you're asking a math question, it's really important to get that answer exactly right. It should be the right addition, the right subtraction steps in order to answer that question. The last category of things that are actually pretty surprising that the teacher can tell the model is training to do is really to take a step back from certain problems and think more slowly about those problems. You could imagine a parallel there to human beings. If I ask a math problem, we could all jump to certain conclusions. Like, if I ask for 7 plus 4 plus 4, I could probably jump ahead and say, hey, that's 15. I could just do that in my head really quickly. But if you ask a more complicated problem, it's probably better to tell that human, don't just jump to an answer without fact checking what I'm saying or double checking the work that I do. Instead, maybe break out a piece of paper, maybe start writing down the numbers as I'm speaking and then add them together. Maybe don't just add all 20 numbers all at once, but add groups of 3 numbers and then add those together. Find different ways where you can get to more accurate ways of doing the addition. That kind of what we call level 2 thinking about how you could answer the problem and thinking through steps you could do, even if those steps might be slower than the initial approach that you took, ends up being really critical to all of us as humans at getting accurate answers, in our own minds to a lot of important questions about the world around us. And so we use a variety of techniques to help encourage the models that we're training to occasionally do that, to take a step back, break down a problem step by step, think about what other tools are out there that the model could use to answer these questions, and then come back to human with a really well double-checked answer that the human could use.
Yeah, great. No, I'm glad we focus on that. I think that's really interesting, and it's just kind of foundational for how this technology works. I think that will inform the context for the rest of the discussion. Let's jump back then to the public sector. I read that Scale were awarded a significant contract with the Department of Defense. So perhaps you can discuss how your work with the DoD differs from some of the commercial projects we've already discussed, and what it means for the future of AI in the public sector.
Yeah, of course. I could talk about some of our work about with the DoD that's public, which is really grounded in this idea that AI can be a transformative technology for public sector use cases across a range of what the DoD does. But it's really important to start by thinking about how we can test these systems. So the work that we do within the DoD is with a group called the CDAO, the Chief Data and Analytics Office of the DoD. This group is really tasked with understanding how AI is being adopted across a range of different things the DoD does. So DoD might think about AI as a way to help solve supply chain challenges, getting equipment to the right personnel at the right time. It might think of AI as a way to help solve paperwork challenges. If you need to document what's happening in a given region, what are ways where I can get ahead of dramatic changes that may be happening, what I'm observing in that region just by synthesizing a range of information. If you think about those different use cases that we possibly use this technology, one common step that we need to take first is understand how do you test the models that are being used for those problems to make sure that those models give reliable answers, and that you can trust the answers that are being given if you're in the field or if you're tasked with being an analyst looking at this particular region. So we spend a lot of time building the test and evaluation framework that the government can use in order to understand how these models perform. And we deploy that test and evaluation framework in a secure way, where it's needed. So for example, if you're leveraging data research that's happening about what's happening in certain cities in the US and how maybe construction of facilities or other places are being bottlenecked, that AI model needs to probably leverage a lot of private data about how that construction's going, what vendors you're using, what suppliers have used over time, how have those been doing on hiring, are there things that you can get ahead of to avoid a surprise 3 months from now that they haven't been able to hire construction workers fast enough. If you think about those questions, it leverages a lot of private data the government has about how these construction projects are going that they might not want to be more broadly available. But you can use an AI model to help look through a range of different patterns in that data and state, hey, construction's falling off track. It's falling off track maybe because I'm not able to get supplies from Michigan to Illinois fast enough. I'm leveraging roads that have been closed off because of the winter or because of some other problems. To get that kind of insight reliably, it's important to test the model in a variety of different scenarios and see, does this model accurately answer questions about supply chains across a range of different things that could ask this model? Does this model accurately state when it doesn't have the right data to answer those questions? Maybe it doesn't have mapping data on how Michigan roads look. So it shouldn't be able to answer a question about how to get from warehouse in Michigan to Illinois. Maybe it doesn't have the right data on how construction hiring is going in a given region or what salaries are looking like. And that's an important part of answering these questions. We use tests and evaluation to figure out how these models understand the world around them and where they're falling apart in that knowledge. So that as a human operator, you could say, I trust this model on topic A, but I'm not going to trust the model on topic B. And I might see directly within an interface, these are the things you should trust the model for. This is the primary data that it has to answer those questions. These are sources that it just doesn't have, and so it can't answer that. That right now, at the state of technology we're in, ends up being the most important thing you can arm a human operator with, is letting the operator know when to trust the model and why you should trust the model's answers, and letting the operator know this is when I have to go back and find more data or more ways of thinking about this problem in order to help have the AI actually be useful.
Yeah, got it. And in pursuit of that objective with these public sector departments, is this where Donovan comes in, which I believe is a decision-making platform that you launched last year?
Absolutely. Donovan is our platform that folks in the government can use in order to answer exactly these sort of questions, if it's shipping or supply chain questions. It incorporates what we call an agent-based workflow, which means that it doesn't just answer a question like an LLM. It doesn't just reply back with a block of text. You can actually ask Donovan to use various tools in order to answer a question. Some of those tools could be using Python code in order to get the right data. It could be querying a data store that you have available. Some of the tools could actually be helping the human understand what they're seeing better. So it could be plotting out on a chart or a graph trends that you're seeing over time, or it could be plotting on a map where different warehouses are. We've found that that's often the missing link in helping these models actually help human beings, is presenting information in a way that humans can visually see what's happening, and help them drive decision making forward. So we're using that across a range of different public sector use cases, and Donovan's kind of our key vision for how agent-based workflows can be made useful going forward.
Yeah, fantastic. And before we kind of round off this journey through Scale's customer base, I want to flip back to the private sector. We discussed the model kind of creators. We discussed the hyperscalers. We talked about OpenAI, for example, Meta as well. But how about these smaller kind of private sector companies? They're behind, obviously, those hyperscaler businesses. So what are the main obstacles these firms are facing, and how are you supporting those businesses and actually releasing Gen AI powered projects?
Yeah, the work that we do at Scale that's the most important here is helping a range of different folks in the ecosystem. And it's actually really impressive now at Gen AI just how diverse and broad this ecosystem is. It encompasses both the large research labs training new models, but also the open source community that's been leveraging smaller models and trying out different approaches with those models. And we've seen a lot of excitement even in industry about using some of those smaller models when they can answer certain questions, certain domains really accurately. The cost advantages can be huge. But also the security advantages can be significant as well. If you can take a smaller model that answers questions about trading really reliably, deploy that within your private data center, what we call a virtual private cloud, that can end up being really important for a bank or financial services firm to trust that the data they're sending the model isn't going to leak out, isn't going to be vulnerable to being infiltrated. So we spend a lot of time working within the ecosystem, understanding what's the best model for the best situation. And we start with testing and evaluation first. So we do our own public evaluation of new models as they're released. We have a group within Scale called the SEAL Lab, which is the Safety Evaluations and Alignment Lab. And this lab publishes leaderboards of new models as they're coming out. We've often found, to no one's surprise, large models perform really well. But we're often surprised at how quickly the progress in the space moves. For example, when Llama 3.1 was announced yesterday, that's actually now the best model in the world by our testing on precise instruction following. So if you're a human being and you're asking for pretty sophisticated tasks from a model, does the model exactly follow what you ask it to? And Llama 3.1 does that more reliably than most other models out there, or pretty much any other model that we've tested to this point. A lot of the testing that we do, really interestingly, not just humans testing these models. So we're not just doing kind of what's called a vibe check in the industry. A vibe check would be you just ask the human, which of these model answers do you think is better? And then, whichever one you pick, that one goes up on the leaderboard. Actually, we do a lot of calibrated testing where we ask humans to explain their answers, or we ask really detailed questions of these humans so that the answers are more grounded in factual statements about how models are performing. And we use ML models to help assist us in that as well. So ML model can help you construct the right answers. It can help you frame the questions the right way. It can do things that the average human stepping up to bat isn't going to know when they're evaluating a model. And so we use these approaches both now publicly within the Scale Lab, but we also do it privately within the Scale Gen AI platform. So if you're a financial services firm, you can leverage that hybrid tooling to do your own evaluation of various models. You can test how they perform on trading desk questions, how they perform on insurance questions. You can use human experts combined with ML tooling to do that testing. You can do it all privately against your own data. So if you're an insurance company and you're holding data about who buys your insurance really secure, you can do testing using our platform within your data center, using only experts that are allowed to access that data. And you can ask them, what are the 10 questions that I would really want to ask in order to understand whether this model understands home insurance really well, or whether it understands medical insurance really well. And what are ways in which the model can be tricked into giving the wrong answer? Like, let's say I ask the same question in Denmark that I asked in Sweden, and the model should really understand, hey, insurance works really differently in those two different markets. You can ask that question in a way that a model could help you phrase it and help you interrogate different models. You can see which model is best suited to answer those sort of questions. That ends up right now being one of the killer pieces to get to actual really strict guarantees about how these models are going to perform and which parts of the system need to be built in order to make this work.
Yeah, I think that's a really interesting application, not something I'd heard of. So if that kind of covers off then private sector, we've spoken about public, we've spoken about those larger hyperscaler businesses as well. I mean, you're working with all of them, and it strikes me, I suppose, that gives you a pretty unique perspective on the industry at large. I wonder whether you're able to kind of harness that holistic insight and actually deliver that through any unique products or services. How does that actually manifest in your offering, do you think?
Absolutely. That's a huge advantage that we have at scale. And one of the biggest advantages we have in the industry is we are not, tied to one particular model. We're not a model provider ourselves, so we're not going to claim, hey, this model is the best because it's the only model that we're going to use. And we're not tied to a particular hyperscaler, but we have great partnerships with the hyperscalers that are really important. For example, we announced a strategic partnership with Amazon to help customers that are on Amazon leverage our GenAI platform to do testing and evaluation of the models that they're using. And they will tell you, models, their customers use models a variety of different ways. They might use Amazon Bedrock. They might host models within their own virtual private cloud. They might be set up in a way that they could use OpenAIs or other models, from Amazon. So being able to test all those different configurations ends up being really important in order to understand what's working within financial services or insurance. And that strategic partnership is going to help AWS customers do that more efficiently and more reliably. We also work really closely with a variety of different firms that are thinking through different parts of this problem. And so we're kind of at some level like able to take a deeper view of how the ecosystem is going to evolve and what are the real barriers that we can overcome to get this technology to the hands of more people. And our finding right now is really, people have two major concerns about Gen AI before they adopt in the enterprise. The first is just performance, that they're concerned that the models might give inaccurate answers. They might give answers that are misleading. They might tell you that they looked across 100 documents, but they actually only looked at 20 documents when they're answering a question, and then you missed something that happened in the other 80 documents. And so we have to overcome those limitations or inaccuracy. And the second is security. I think everyone's really concerned, and actually, I think certain surveys have showed if you talk to large enterprises, almost 30% of them have already had at least one security incident related to generative AI. Whether it's through adding a model in a way that wasn't secure, or whether it was leaking data internally within an organization. So I think in order to overcome those security considerations, we have to find better ways of building these AI systems that have the right guardrails in place. And we're spending a lot of time on that part of the equation today too. What are the guarantees you can put around generative AI to make sure your data doesn't leak? You're not revealing something that's harmful to a human user or is harmful to your customers. What are ways in which you can really understand how the whole AI system as a whole is performing, so that you can understand that all the pieces are coming together are still pretty secure.
Yeah, fantastic. I know it's something that the business I work for is thinking about as well. I want to finish with a couple of questions on the wider kind of AI industry and any future innovations you've got your eye on. Perhaps we can start. I think it was at a conference you were relatively recently speaking at that you were asked a question about the kind of regional competition, I suppose, in terms of like the AI arms race, ethical considerations that need to be taken into account as a result of that. I think you were asked maybe about the attraction of kind of top talent, top AI talent as well, who's currently on top in terms of that competition. So perhaps you can just speak to that wider point of regional competition from an AI arms race perspective.
Yeah, we call it the war for AI talent, and it's a war in the sense that AI talent is now incredibly rare to find. People with experience working with generative AI in an academic setting, or maybe have done it at scale at a large research lab. You may look at any one of these roles that you need to hire for in order to build AI systems. You may find there are only like 1,000 or 10,000 people on the entire planet that really have a lot of experience working in this particular area or subfield, who are really qualified to do this work. So right now there's a huge heated competition to try to hire the right folks into the right positions in order to build the future of these AI capabilities. You're going to see that only accelerate going forward. I mentioned how quickly this technology is advancing, and the models can do things with code today that they couldn't do before. I think a year from now, you're going to see advancements in multimodal capabilities and the ability to work in embodied agents and the ability to build really interactive experiences for people, maybe the applications from beginning to end that human beings could use. But in order to build those capabilities, you need to find the right talent that understands those domains really well and understands how to put the pieces together to make these AI systems work. work. And that talent is very hard to find right now. So as a result of that, we know that here in the US and in the UK, we're finding really talented engineers, machine learning researchers. We're bringing them together in new and interesting organizational structures in order to build these systems. And that work is very important. We've also seen in other countries like China, they also have, really rich pools of talent. And in some ways, they've been racing ahead with developments in AI by using a lot of the talent that they have there. And so we kind of feel like we're in this big now global competition to see, can we push things ahead forward, with a little bit of what we have as special capabilities where we can be a little bit more open and transparent about the work that we're doing in AI and what the safety risks of these models might be in a way that, another government might not be as forthcoming with stating, hey, these are cybersecurity risks of models that we're training or other things that could be of consequence to the security state of the world that we're in. As part of the war for AI talent, we're constantly mindful of that. This is incredibly powerful technology. It comes with certain risks, and potentially, racing ahead means we can get ahead of certain global competition around this risk.
Yeah, got it. And so I guess that heavily relies on the local kind of administration or government needing to be relatively receptive to these ideas and working with the technology. I think you have an office in London. We were chatting before the call. To what extent is that because the UK government is relatively receptive to the technology, and are you actively working with them to implement it?
Yeah, we just announced earlier this year our first international office, which is in London. And so that's going to be an important locus point for us for a couple of reasons. One is there's a lot of important AI research happening in the UK that always has been. I think, you could point to DeepMind, you could point to Meta, you could point to, folks that large international research labs that have offices there, but also a lot of homegrown research that's happening in the UK as well. The second is the UK has been a really important leader in thinking about AI safety at a core level. We participated in the Bletchley Park Summit last year, which brought to mind a lot of important AI safety considerations. And so we've been really fortunate to get to partner with the UK government on some of those initiatives, specifically talking about testing and evaluation of these models for safety reasons. When can you understand that a model is producing harmful outputs? When can you understand that the model's ability to write code suddenly means cybersecurity has new things to consider when building more secure systems? The UK has been a leader in thinking through those ideas and offering them across the global community. And the last third point is, I think the UK is becoming a really important area for a lot of international work that's happening. So as we think about ways in which this technology can be used, not just in the US and Canada and other parts, but we think about how it's going to be used in Europe, and we think about how it's going to be used, across maybe even the global South in the future. London's a really good starting point to start thinking through those use cases. And for some of the financial services firms we work with, some of the telecommunications companies we work with, they have really global footprints. And so London's a really important starting point for them to think through those international issues.
Yeah, fantastic. Okay, well, I want to finish with a final question. The tagline of the podcast is invest in the next big idea. So I want to think about the next big idea and ask you for a prediction of sorts or a key trend or innovation you've got your eye on within the industry. Perhaps if we use the time horizon of the next 5 years, let's say, what specific trend or innovation are you particularly excited about in this space?
Yeah, I mentioned briefly embodied agents, and the reason why I'm excited about that term is it means models that aren't just tasked with doing a specific thing in the real world, but actually generally capable of helping human beings do things in the environment around us at a level that we didn't think was possible before. So example of an embodied agent could be a robot with 2 arms. And as a human in my house, I could tell the robot, go wash the dishes for me. And the model understands by seeing a variety of ranges of data about different kitchens, about, different sort of tasks people do in their kitchen. It understands what that task is and how it might go about doing it at a level that I would expect, myself to be able to do it or any of my family members to be able to do it. That is really a game changer to think about a future of AI robot assistants that can do things at the level that humans can do them. It doesn't necessarily mean that we are on the pathway to just, general intelligence or sentience, but it does mean models that are more capable of helping human beings. And maybe as a starting point on that path, helping understand the world around us, learning a lot from the world as they're experiencing it, learning a lot of different options for doing different things in that world, and using that experience in order to inform the future of how we interact with this technology. To me, embodied agents covers a lot of that. It's the moving beyond just kind of text and images and the things we're asking the models to do today, but actually interacting with the real world around us.
Yeah, really interesting insight, an exciting insight, I think, to end on. That just leaves me to say thank you very much for joining me on the podcast, Vijay. It's been a real pleasure.
Thank you very much. It's been really exciting, and hopefully better weather in London. It's coming
Yeah,
your way.
fingers crossed.
Yeah.